Today we're going to start the last section of Chapter 7, focusing on natural logarithms. We've been looking at logarithms and using something called a common log, which is base 10. Today we're going to focus on natural logs, which is a different base. So our targets today to evaluate and simplify natural logarithmic expressions and to solve equations using natural logs, which will be tomorrow's part of this lesson. The function y equals e to the x has an inverse, the natural logarithmic function, y equals log base e of x, or y equals the natural log of x. So when you see this symbol, we usually use a script font. The natural log of x means we are looking at log base e of x. So common log uses base 10, natural log uses base e. The function y equals e to the x and y equals the natural log of x are inverse functions. So just as before, if a equals e to the b, then our base is e, our power is b, so we can say log base e of our main number equals our power. Okay? But instead of always writing log base e, we can shorten that into just the natural log of a equals b. So what we have in the picture here is the original y equals e to the x. Okay, that's an exponential growth curve, right? Our base is e, which is 2.718. And then in green, we have the natural log of x. So that's the inverse function. Remember, we just reflect over that y equals x line, and we get our inverse picture here. Okay, so remember when we graphed logs, that's what they looked like. They came up along a vertical asymptote here and then curved off to the right. This is just using log with a base of e. So we have had some experience with e. Back in 7.2, we used it when we were doing that PERT formula, right? Compounding continuously. But in order to solve for our power, we had to make a table because we didn't know anything about logs. So in this section, we are going to look at algebraic ways of solving those equations. So before we get to solving equations using natural logs, let's discuss how to evaluate them and apply the properties, just like we did with other types of logs. So remember when we evaluated log base 4 of 2, we said 4 to some power should get us a 2. Okay? And then we looked at what do we do to a 4 to turn it into a 2? We would have to square root it. So our power would have to be a 1/2 or a square root. In the second example, 6 to some power should get us that. And thinking about what we do to a 6 to turn it into 1/36, we know we have to flip it, so we know it's going to have to be a negative power. And we are taking a 6 and turning it into a 36, so we are squaring it. So squaring would be a power of 2, flipping it would be a negative 2. Our third example, we have the common log of 10. Since there's no little base, it implies a base 10. So 10 to what power should get us a 10? And so x would have to just be a 1 here. And then we had the expression a to some power should get us a to the 7th. When our bases are the same, our powers have to match, so x would have to be 7. And this last property really just says if you take the log base a of a to a power, these are going to drop out. Your answer is just the power. So let's evaluate some that have an e instead. When you see natural log in your mind, you should be picturing log base e. We don't write it in there, it's just a shorter way of writing it, but that's what it means. Natural log of e to the 5th means we're looking at a base e. Since these bases match, our answer is just our power. For this one, we have 5 times log base e of e. Our power here is just a 1, our bases match, so this really turns into 5 times 1, which would just be 5. For this one, we have a square root over the e, so let's think of this as the natural log of e to the 1/2 power, And again, natural log means we're looking at a base of e. So these drop out. Our answer would just be our power, which would be 1/2. So we can also use the same strategies as before to condense or expand our log expressions, even when they have a natural log instead. Okay? So remember that front numbers, those coefficients, have to go back as powers. So this becomes the natural log of 6 squared minus the natural log of 27. And then we can simplify 6 squared to be just 36. And then when we have subtraction of two logs, we can condense that back into division using that quotient property. So this becomes the natural log of 36 divided by 27. And we could reduce that fraction down to 4/3, dividing by 9s. So we've got the natural log of 4/3. Okay, for our second example, again, we see a subtraction sign, which means we have a quotient, we're dividing. So this becomes the natural log of 10a squared divided by 5a. And then if we reduce that, we can take 10 divided by 5, and we get 2. And a squared divided by a is just a. So it becomes the natural log of 2a. Our third example, notice that the 1/5 is outside of some parentheses. So let's condense the stuff inside, clean this up. When we see a plus sign, it means multiplication. So these are condensing back into the natural log of 8 times x. And then a 1/5 in front is going to go back as a 1/5 power. So we have the natural log of 8x to a 1/5 power. And you can leave it that way, or you could convert that 1/5 power back into a 5th root symbol. Okay, either answer would be fine. So doing the reverse direction, expanding, we have a product here, we have a power, and we have a quotient. So we are using all three of our log properties. Let's pull apart the quotient first. So the natural log of 11x cubed. So, division expands into subtraction, so we're subtracting the natural log of z. And then we can separate this multiplication here, because multiplication can be expanded into adding two logs. So this becomes the natural log of 11 plus the natural log of x cubed minus the natural log of z. And then our last step would be to move this power out front, but it only applies to this x piece. So we're just going to move it in front of the natural log of x. Final answer, natural log of 11 plus 2 times the natural log of x minus the natural log of z. All right, go ahead and pause the video and try this last one, and then turn it back on to check. Okay, let's see what you did. I see powers, both a whole number power and a fraction power, that cube root, and I see multiplication. So let's pull apart the multiplication. We've got the natural log of e to the 4th plus the natural log of the cube root of y. Now this first expression, the natural log of e to the 4th, remember natural log means log base e. So we really have log base e of e to a power. When those bases match, the log piece drops off and we just have our power. So this really is going to simplify down to just a plain 4. For the second part of it, we have a cube root, which is a 1/3 power, and powers get moved out to the front. So you should have 1/3 times the natural log of y. So 4 plus 1/3 times the natural log of y.